1. The x plus 3, should that move to the left or the right? Left 3. And do I move up or down because of this minus 5? Down 5. So my vertex, if I go left 3 and down 5, would be at the point -3 comma -5. I'll come back to AOS. It stands for axis of symmetry in just a minute after I graph this, but AOS, you might see LOS, line of symmetry. It's just an abbreviation. So I'm going to go to the point -3 comma -5. I'm realizing this is kind of a small grid here, so hope it doesn't strain your eyes. What did we say that the parent points are? When it's a quadratic, we go over 1 and up 1 unit from the vertex. I'll zoom in on my graph here. So I go over 1 and up 1, and then over 2, up 1, 2, 3, 4 would put me here. And it's symmetrical, right, on both sides. And then if I go over 3 from the vertex, I have to go up 9, because 3 squared is 9. So if I'm at -5 plus 9, I would be at +4. And symmetrical will be over here. Does that look good? So the points of the parent function are over 1, up 1, over 2, up 4, and then over 3, up 9. So I did the parent function coming from that vertex. You square the x value. So if you're going over 1 unit, what's 1 squared? 1. If you're going over 2 units, what's 2 squared? 4. And if you're going over 3 units, what's 3 squared? 9. So you're starting, this is like base camp. This is usually starting at the origin, and then you're opening from there. So like you're moving your starting value, and then you're doing everything from that point. I'm making my thing jump. All right, so that is the parent function that's been shifted. Where is my axis of symmetry? So if I cut that in half, what x value am I slicing right through? -3, right? So the axis of symmetry basically corresponds to the x value of your vertex. And it's a vertical line, so you write your equation as x equals -3. An axis of symmetry is like you can fold it in half. So when I'm graphing, like when I go over 1 up 1, I put my point there, and at the same time I put my point there, right? Because it's a symmetrical graph. When I go over 2 up 4, I'm putting it here. Why am I putting it here? Because it's symmetrical. So axis of symmetry means it's symmetrical.
Or you could just put like the first part of the vertex.
Yes, it's the first part of the vertex, yes. So this -3 corresponds to the first part of the vertex, yes. All right, I purposely skipped number 1 because this graph has been stretched. This 2 is going to stretch our graph, and so we haven't done that really yet. What do I do with this x plus 4? Does that go left or right? Left 4. I'm going to put a +0 out here to show you that this has not moved up or down. So I'm just going to write up or down 0. So if I'm going left 4 and then comma 0, that's going to be my vertex. So put a dot at your vertex, and if you use Poppy's shortcut, you know that your axis of symmetry is just going to be the first part of your vertex. X equals -4. Or you could graph it first and then realize that. All right, so here is kind of the part I wanted to get to today and add to our notes from yesterday. If you are doubling the height of a parabola, if your normal points over here were 1, 1, 2, 4, 3, 9, we're going to now double these heights. So if I double 1, I'm now at 2, right? If I double 4, I'm now at 8. If I double 9, I would be at 18. So from your vertex over here, you're going to go over 1 and up 2 units. Because normally you would go up 1 unit, you need to double that. Normally, when I go over 2, 2 squared is 4.
Why did it change?
Because of the 2 in front of the function. So when you go over 2 this time, you're going to go all the way up to 8. So this graph is twice as steep as the graph you did in number 2. So we're going to add this in a second to our resource page so that you know this time we went over 1 up 2 and we went over 2 up 8. If I wanted to go over 3, I would have to go up 18. Right? Because it's really 1 times 2, and it's really 4 times 2, and it's really 9 times 2. So I'm doubling the normal height of the parabola.
Wait, what is axis?
Axis of symmetry is the x value of your vertex. So there's this vertical line right here that cuts the graph in half. That's like a mirror image. You know the term, what goes up must come down?
Yeah.
That's why a projectile, right, if gravity is acting on the projectile, it gets to its peak and then it falls back towards the earth. The gravity is creating the symmetrical motion through the air. There is some wind resistance, but if you don't take that into account. All right, so what's different about example 3? Here's another one where there's a change in front of the function. There's no change after the function, so I'm actually not shifting left or right. My vertex is still just at 0, 0. So that tells me my axis of symmetry is also at 0. And this one's kind of hard to see because you're shrinking everything times a half. So let's just write next to this graph 1, 1, 2, 4, 3, 9, and 4, 16 is our original. What's half of that? Right, we're cutting these values in half. That's supposed to be a half. What's half of 1?
Well, I should go lower too.
What? A 2?
I hiccuped and said bless you at the same time.
Oh. Yeah.
Would it also work if you just doubled the x value? instead of
No.
half? Okay.
I'm not sure why that doesn't work, but it doesn't work. I'll show you. Half of the height would be at 2, 2. Maybe it would work. Hold on. Half of the height would be at 3, 4.5, and half of the height would be at 4, 8. You're only changing the height of the function. That's why I kept emphasizing that it's a vertical stretch or a vertical shrink.
What if you just left the y value the same as double that value?
I don't know. So what would yours, if you followed your rule, what would your set of points be?
What are you doubling?
1,
2, 1 doesn't show up over here though. I'm doubling the height of, oh sorry, I'm cutting in half the height of my graph, right? Instead of a height of 1, what's half of 1?
What if you did an extra point between, wouldn't it, if you double that, wouldn't it be?
I don't know. When I plot my points, I will test your theory. So I'm at a half, I'm at 2, 2, I'm at 3, 4.5, and I'm at 4, 8. Let's see if you test your theory, does it work? These are the points that I just graphed. Half of the height. So this is the parent function. This is what it looks like when it's half parent, and then this is what it looks like when it's times like 2. So it's doubled, it's steeper. They all start at the same point. So number 1, 2, and 3, if you compare them, they should have a different steepness if you were to overlap them. And to me, that's the hardest part, is stretching or shrinking it. I think you guys are good with vertex form. Where does the vertex go? The hard part, why was it easy with absolute value? It was easy with absolute value because all you're doing is changing the slope of these lines, right? This would just be absolute value of x. If you double it, you're just changing the slope of the graph to positive 2.
Yeah.
Or you're changing the slope of the graph to 1/3. So
Yes.
so it's easy with absolute value. Because this is a quadratic relationship, you're doing things to these y values and they're not consistent, right? Because it's a curve, it's not a straight line. It makes it a little harder.
Doesn't drive the same.
It doesn't work, yeah, so don't double x. X stays the same, you're changing the height of the graph.
I'm so confused.
So 1, 2, 3, 4 has not changed, okay? 1, 2, 3, 4 has not changed. Are you good with where these values came from originally?
No.
Okay, the function is called y equals x squared. What is x? 4. What is 4 squared? 16. What is x? 3. When I plug in 3, 3 squared is 9. So this is the original function that we already talked about. This is doubling, so this is y equals, well this is actually half of x squared. So I'm taking half of this value.
Enough.
And this is the set of points that I just graphed over here. So that's a parabola with a height of a half. Half as tall, half as tall. So if you can get in your head that the y values are changing, but the x values stay the same. That's why I keep calling it a vertical stretch. What is the vertical variable? Y. Question? Can you wait till we're done with number 4 and then yes? Okay. So number 4. This one's easy because there's 2 changes. What does the negative do?
Flip it over.
Flips it upside down. What does the 3 do? So 0 left or right. I'm going up 3, so I'm at 0, 3. Axis of symmetry, if you're catching on, is the x value from your vertex, because it's a vertical line slicing your graph in half.
Wait, do we go left or right?
We're not going left or right at all. We're starting at the origin, and we're only moving up 3. So I'm going to put my dot at 0, 3. What does the negative do? It makes my parabola open upside down. So I'm going to do the original parent function. Oops, sorry, you can't see any of this. Kind of hard to read, isn't it?
The turtle looks like he's trying to escape.
Oh, I told you I was going to let him walk around during the quiz. Or was that my other class?
I know.
I don't know. They were asking. Can you see this now? So I'm going to use the original parent function in the downwards direction. So 1, 1, 2, 4, 3, 9 going down. So I go over 1 and down 1, over 2 and down 4, and over 3 and down 9. It's going to put what, -6? This is the normal parabola. So the parent function parabola opening down. So this was over 1, down 1, over 2, down 4, over 3 from the vertex, down 9. I'm just going to shut this for one second at all. So why don't you just tell me on the back page, what does this -9 do? What does -9 do in the parentheses? Good guess.
So up.
Also a good guess.
Right.
Right. You have a 1/4 chance of getting it right. It's either up, down, left, or right. Okay, what's happening in part B?
I'm going left.
Left, and what's happening in C?
Right. 5.
Okay, so we're just changing the graph by moving it to the left or to the right from 0, 0. So I'll do A, and then you add B and C. So I'm going to go all the way to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess this is a 10 by 10 grid, so that way you don't have to count. I'm doing the parent graph. So not all of my points are going to fit, but over 1, up 1, over 2, up 1, 2, 3, 4. I'll just graph it so I can graph the whole thing here. And then over 3, I would be up here at 9. 1, 1, 2, 4, 3, 9. It's a smooth curve. So now you try to add B and C. So you're doing the parent function over and over and over to get really good at those set of points. So add B and C on the same axis, and then we'll go down to the bottom one together. Trying to get lots of practice on quadratics.
So we going backwards?
So now you're going left 2, and you're going to draw the exact same graph at -2. So you can look up when you're done. I'll just work on putting mine up so that they're on this video. This is exactly what you're doing on tonight's homework practice, is vertex form graphing. Rate 5. This is A, this is B, this is C. What did you do that was wrong? Oh.
What are the numbers? One,
1, 1, 2,
2,
4, and 3, 9. Because 1 squared is 1, 2 squared is 4, 3 squared is 9. You're squaring your x value. So, a good question would be, where do these two quadratics intersect each other? And I think these intersected at that same point, didn't they? If I had drawn it a little bit neater. These two intersected and shared that point in common. Which they should have gone right through the same point, but. Remember how we had to solve like linear systems? But. Can I go to the bottom?
Yeah.
All right, tell me the transformation rules on the bottom. These are all ups and downs. So what does the plus 8 do? Up. What does the minus 5 do? Minus 5 goes down. Minus 10 goes down. So if I go up 8, I'm not going to be able to fit very much. Let's just do the first couple points. If I go up 8, my vertex is here. I'm just going to go up 1 over 1 and kind of show that it would be a quadratic graph. Let's just graph the first set of points. If I go down 5, 1, 2, 3, 4, 5, I'm just going to graph the first set of points just to save time. Just do the 1, 1 in either direction. And then go ahead and add the down 10 one. So just comparing, how is number 2 different than number 3? Number 2 shifts left and right, number 3 shifts up and down. So if I was down here at 10, it would look like that. So just showing what vertical shift looks like and horizontal shift. There's one more thing I want to just add before we go away from this on your resource page. Can I go back to the resource page? Just remember I said I was going to add the parent points for a transformation. If you go back to R2-9, because we've already listed the parent points, I wanted you to just list 1, 1, 2, 4, 3, 9 one more time to show how it changes when you multiply by 2. It's exactly the points that I had written on the board before. 1, 2, 2, 8, and 3, 18. You're doubling each of the y values, but the x value stays the same. So this is on resource page 2-9. The last thing I'm going to have you do, because we still have 4 minutes, but we'll just add this and we can be done. Doubling the y values. And then what if we multiply by 3? So now we're going to triple. I'm going to rewrite 1, 1, 2, 4, 3, 9. I'm going to triple the y values this time. So this is the parent set of points. What do I get when I multiply them by 3 this time? 1, 3, and 2, 12, and 3, 27? That one would never fit on our graph, but. So do you get the idea? You're doubling the y value here, you're tripling the y value here, and we're going to half the y value here. That way, if you ever need to flip back to this page, okay, what is times 2 or what is times a half? I'll just add this last one and then, oh, I should go in the same order. Hold on. 3, 9, 2, 4, and 1, 1 times a half. 3, 4.5. 2, 2. 1, 1 half. Oh, and then you can circle what got changed if you want. So you've got homework 2-4 to try to get done for tomorrow. Some of you already did it before lunch. It's all on practicing vertex form. What'd you say?
I